All right, just going to do a couple of solutions to questions I gave you to do, just reviewing everything on applied measure or area and volume. So get out the questions you did and submitted to me on those. Get out the questions as well, because I would say my rough diagrams here are slightly less than perfect, we'd say. But I will go on and start them now. So question 1. Question, taking pi equal to 22 over 7, find the area of the shaded portion of the given figure. So I've got a square. Okay, it looks like a square from the diagram. We'll show that it is a square in a second. And then inside it, a circle. I'm asked to get the kind of bits which are outside the circle, inside the square, the kind of shaded bits around the outside here, get the area of those. So look, I can't do that directly. All right, there's no formula for those sort of shapes. What do I know how to do to get the area of a square, to get the area of a circle? So if I get both of those answers and subtract them from each other, that will give me the area of the shaded area from the diagram. So how do I get the area of the circle? It's pi r squared. So it's page 8 in your log tables. Area of a circle or disk is pi r squared. So area is equal to pi r squared. Pi, I am told to use 22 over 7. You will lose marks if you do not use the value they tell you to use. So 22 over 7 multiplied by the radius squared. The radius is marked in on the diagram as being 7. So 22 over 7 multiplied by 7 squared is 154. You'll find they often tell you to use 22 over 7 when the radius of the circle is some multiple of 7. So that, it'll cancel and you still get a nice round number like that. But don't worry about that. It'll tell you what to do, as I said. Now, I need to get the area of what is a square as well. Okay, so how do I know it's a square? Well, the radius is marked on the circle, okay, and the circle fits exactly inside the square. So the radius of 7 is marked on there. That means from kind of here to here is also 7 because that's a radius, and from here up to here is also 7 because that's a radius. So if that's 7 and 7 is 14, that's the same as one of the sides of the square. Okay, and then same thing over here. Radius is 7, radius is 7, so the entire dimension is 14. Okay, so that's how I know it is a square. I can get the two dimensions like that. So the area of the square then is just length by width. So that's 14 by 14. 14 squared is 256 maybe. 196. 196. So area of the square is 196. Area of the circle is 154. So the difference between those is going to be the shaded areas out here. So just subtract the two of those from each other and you'll get your answer. Okay, so 196 take away 154 is 42. This is our final answer on the question. So you should give your units in the question. That 7 is centimeters. This is area, so it will be centimeters squared. All right. Question 2 then. So we've got a running track in the shape of a rectangle with semicircular ends. Okay, so it mightn't look exactly like it from my diagram, but this is a semicircle and this is a semicircle, and then you've got kind of a rectangle in the middle. So you can think about these as two semicircles, or it might help later in the question to kind of push them together and they're a full circle. I don't know what the question's going to ask me to do. We'll see. Calculate the length of the track. Take pi equal to 22 over 7. How many laps would an athlete need to complete in a 10,000 meter race? Okay, so how long is the track? Well, this bit's 101 and this bit's 101. That's given in the question. So that's fine. That's 202 meters. What's the hard part of this is to figure out how long is that curved bit, and how long is that curved bit. Okay, so you can think of those as semicircles, or as I said, you can kind of push them together nearly. And they're two semicircles, so together they're going to be a circle. Okay, this entire kind of length here, okay, so like the diameter of our circle is 63. All right, so if the diameter is 63, it's probably the radius we'll use, because it's the radius that's in all the circle formula, so that the radius is 31.5. All right, so we're looking for the length of this curve here. So we're looking for the circumference of the two semicircles. Or another way of thinking about that is the circumference of that entire circle if you were to push those together. Okay, so the circumference or length of a circle is, again, on page 8, it's 2 pi r. So length is equal to 2 pi r. So that's 2. I'm told to use 22/7 for pi again. And my radius is 31.5. So 2 by 22/7 by 31.5 is 198. And just remember, that's the entire circle. So that's this end and this end together. Okay, so one length of that track, or the length of the track, is 101 plus 101 plus 198 is the entire two ends. So if you add those together, you're going to get 400 meters. All right. If you did the semicircle separately, the formula for this, it would just be 2 pi r by a half. You do it twice and then multiply your answer by kind of 2, or you'll have two things to add on here. You'll get the same thing in the end. But there's the length of your track. Second part of the question, how many laps would an athlete have to complete in a 10,000 meter race? So how many 400 meter lengths are in 10,000? So it's asking you to divide 10,000 by 400. So on the calculator, 10,000 divided by 400 is 25. And then laps, I guess, will be here. All right. So whenever you've got kind of a long question, or you've got a good bit of work, and not a bad idea to maybe highlight your answer or put a square around your answer, just make it easier for the person correcting it. Because if they see the two correct answers, grand, full marks, and they move on, rather than having to kind of dig through a lot of workings to get it. Okay, it's not too bad there, but in other questions you'll have loads of workings, and just kind of tie it up in a knot for the person who's correcting it. Question 3 then, what's the length of the radius of this circle? So I'm given the area and I'm looking for the length of the radius. So this is typical enough in area and volume questions. I'm nearly given an answer and I'm looking for something in the formula. So if you're given the area, let's look for the area formula. It's here, and it's pi r squared. Okay, and we are told that the area is 25 pi. So we're going to try and solve this. Okay, pi r squared is equal to 25 pi. All right, don't forget, pi is just a number. It's 3.14159, etc. All right, it's not another unknown. So the only unknown I have here is the radius, is the r squared. As long as you only got one unknown, straightforward enough to solve using algebra. So the first thing I would do here is I would cancel the pi from both sides. Okay, divide both sides by pi. And it's gone. So you've got pi on both sides, you're allowed to divide both sides by pi, and they cancel. All right, that's why we leave these in terms of pi sometimes. You get nice results like that, and it makes the questions kind of straightforward enough. So then what am I left with? I'm just left with r squared is equal to 25. It asks me for the length of the radius. So if I know r squared and I want r, it's square root. Or is the square root of 25, so r is 5. In the question, it was in centimeters squared, so my radius will be in centimeters. And there's my answer. All right. Question 4 then, what's the area of the shaded cross section of this triangular prism? So the shaded cross section is the triangle that kind of at the front. All right. And it's a prism because it's a uniform cross section. If you were to slice this prism down anywhere, you'd expose a face identical to the one at the front. Okay, so if you were to cut that anywhere, you'd get an identical triangle as you've got there. Okay, so that's kind of our working definition of a prism. So it's asked me for the area of that triangle. So let's maybe draw that out on its own. Ignore the prism for a second. What do I know? I know what's marked on is its perpendicular height. So they've got a little right angle symbol here to tell me this 7 is the perpendicular height of the triangle. And it's got an 8 marked on as being the base. So can I get the area of that? Yes, I do have the information I need. I've got the base and I've got the perpendicular height. So the area, the formula for area of a triangle, it's page 9. There's a few of them. A half AH. So A is marked on that diagram as the base, H as the perpendicular height. So that's the formula you need. That one you won't do till leaving cert. The other one you'll never use in secondary school. So this is the only formula you need here for a triangle at junior cert. So a half AH. So to get the area of that, you can say a half AH, or you can use a half BH. B for base, it doesn't really matter as long as you sub the right thing in. So it's a half by the base is 8, by the perpendicular height is 7. So on the calculator, if you do a half by 8 by 7, you will get 28. And those dimensions are in centimeters, so this will be in centimeters squared. And that's my answer for part 1. Next one is the volume of the prism. So volume of prism formula is here in the log tables. Okay, solid of uniform cross section. Taking B to be the area of the base, it's BH. So it's the area of the base multiplied by the height. Okay, so it's not the easiest one maybe to use from the log tables there. It's the area of that uniform cross section multiplied by the depth of the shape, or how far that uniform cross section goes back. Okay, so it's going to be the 28, the area of that triangle at the front, multiplied by the 9. However far back you could cut and reveal that uniform cross section. Okay, so if you want to write down the kind of formula, it is BH is what's there in the log tables, okay, with B just being the area of this thing. So 28 I've figured out already, multiplied by 9. So on the calculator, 28 by 9, 252, and that's volume, so that will be centimeters cubed. And that's your answer for part 2. All right, I'll finish these off then in another video.